Hello students, I am Dr. Sanjeev Punia. In computer graphics, last lecture we discussed about 2D transformations where we studied about different forms of transformations like rotation, scaling, reflection and many more. Means we saw different type of transformations, that is operations we can perform on 2D images. In today's lecture we will discuss about window and viewport transformation. This is very important topic, as always in the final exam there is one question among this topic, and generally that's a numerical based question. So here we will discuss about the word, that is what a word, what's the coordinates of the word, what is window, what is viewport, the difference between the windows and the viewport. Then we will discuss about the coordinates of the window as well as viewport. Later then we will discuss about the mapping of an image or object from window to viewport. And in the last we will discuss an example based on window to viewport mapping. So let's start from the basic of window to viewport. So when we have to discuss about an object from window to viewport, then first of all we have to discuss the original object. Original object means, suppose I want to click a picture of any object, then whatever we are seeing in the background, that is the world. That's the world image. And whatever we want to take, whatever the picture we want to take, that's the window. And viewport is the picture whatever we have taken. It's not necessary that always we have to put that image in the same dimensions. Maybe we have taken the image and the image is of size 10 to 14 inch. Maybe later on we have to enhance that image, or we have to diminish that image. So world image is whatever the complete picture we are seeing, that is called the world image. The window image, whatever we want to see, only whatever we want to see, that's the window image. And viewport means where, what is the dimensions of the display where we want to see that object or image. So word are the, in the broad sense, all the backgrounds of the image. Window is the image only, the part of the image that we have to see. And viewport means where we have to show that image. So the size of the window and viewport can be different. We will discuss this in within a moment. I will try here to show this by an example. See, this is a word coordinate. Word coordinate means this is the image, or this is the background, whatever we are seeing behind. For an example, you can consider that this is a image. This is the complete image that we are seeing. So this is a world image. This is a world image. But I want to take the picture of this part only. I want to take the picture of this part only. Or in another way, I can say that this is my window. If this is my window, then this is the only part. This is the only part of the image that comes in my window. Means only and only this part will be shown to me. So this is called window and this is called the window image. So this is a world image. This complete is a world image, and this is the window image. This is the window image that I am seeing. The coordinates of the word. The coordinates of the word is from 0 to infinite on x-axis to infinite on x-axis, and minus infinite on negative axis, to infinite plus infinite on y-axis, as well as minus infinite on y-axis. In simple words, the coordinates of the word image are minus infinite to infinite in x direction, whereas minus infinite to infinite in y direction also. This is about the word image as well as about the word coordinate. Now, whatever the area we want to see, that is called the window. That is called the window. And the image and the part of the world image and the part of the world image that comes in between window, that comes in between window, that is called the window image. That is called the window image. And there is the x coordinate, minimum x coordinate, maximum x coordinate, minimum y coordinate, maximum y coordinate. Means the size of the window is always fixed. That is on x axis there is x minimum and x maximum, whereas on y axis the size of the y minimum and y maximum. I told you that on world window, so not sorry, don't say window. On world coordinate system, there is this is the area from minus infinite to plus infinite on x-axis, whereas on y-axis also this is minus infinite to plus infinite. But here you can see that in case of window, area is, or size of the area is defined. So it's from xw. W represents window. W represents window. So x represents x coordinate. So this is x coordinate, means on x axis the coordinates of window are minimum, and on x-axis coordinates of the window are maximum. So these are the maximum coordinate on x-axis, and these are the minimum coordinate on x-axis. Same, this is the minimum coordinate of window on y-axis, and this is the value of maximum coordinate of window on y-axis. Now, in the simple way, we can discuss this in means when we are going to simplify this diagram. In this diagram, I show you the complete image, means world image. But to simplify the things, I am removing the part of the image that is outside the window. That is outside the window. So this is the part of the image, and this also, these are the parts of the world image that is outside the window. So I remove this part, and as well as this part also. So these part of the world image are outside the window. So for the simplicity purpose, I am not showing this over here. I am not showing this over here. So now we will try to understand it again, and it will be more clear now. See, we were discussing about the window. So this is a window, same. The size of the window is same. The size of the window is same. Like it was xw min, xw min, xw max, xw max. This is also xw max. This is yw min, this is yw min, and this is yw max. This is also yw max. What I did in this, I removed the image that is outside this window part. So this is called now device coordinates. This is called the device coordinates, where I want to the image that I want to see. These are the coordinates of the image, of that image, and this is the world coordinate. So we are not concerned about the world coordinate. This is for our understanding that how we can represent a world image to a window image. Now it will be more clear from the next slide, because I draw a picture over there. So from here you can see this is a world coordinate, this is a world coordinate, this is the background, this is the complete background of an image. But I am interested not in all the image, I am interested only this part, only this part. So this is the size of my window. This is the size of my window. This is called XW minimum. As we discussed, the size of this on X axis, XW maximum, YW minimum, and YW maximum. So this is the size of our window. Now, as I told you, it's not necessary that whatever is my window size over here, I have to represent that image or that object on the same size of display. Maybe I have my window size this, that is, for an example, 15 is to 12, 15 is to 12, and I want to display this image on a area where the coordinates are, 30, and maybe it's 15. Maybe it's 15. Or maybe it is a small area. Maybe it is a small area, that is, for an example, the size on y-axis is 5 and on x-axis this is 10. So there are two possibilities when I want to view a word image on the viewport image. So this is where my size of the image is going to be enhanced, and size of the image in this case is going to be decreased. So this is the reason we are saying it viewport, and the coordinate of the viewport we are representing by xv instead of w. Here w represent window, and in this case in viewport we represent view. So we have two different view of an object. This is the original object. This is the coordinate of an object. This is xw, means original window minimum coordinate on x-axis, window maximum coordinate on x-axis, window minimum coordinate on y-axis, and this is the window maximum coordinate on y-axis. So this is the size by which we can define the size of the window, and whatever the image inside this that represent the image window image. And when we are mapping this word window on another port, on another window, that may be enlarged or that may be diminished, then in that case we will call it viewport, means where we want to see, where we want to view that image, that's the viewport. And the coordinates of that is on x-axis, that is v min, means viewport minimum coordinate. This is viewport maximum coordinate on x-axis, whereas view minimum coordinate on y-axis and view maximum coordinate on y-axis. So now we will try to find out that how we have to map this. Our purpose over here is to find out we are not concerned about the world image or world coordinate. What is our motto over here? That a image will be given in the window part, or then we have to find out the corresponding image in the viewport. This is our motto over here. Our motto is window and viewport mapping, means how we can port an image from window to view. For an example, as we discussed there, this is a window and we have to show the image of this window in viewport. The mapping of window to viewport is also called viewing transformations. Viewing transformation or windowing transformations means we are transferring from window to view or view to window. That sometimes there are questions like this that we have to map a window to viewport or viewport to window. So there can be both type of questions. First question can be that we have to port an image from window to viewport, or in second we have to port an image from viewport to window port. This is also called viewing transformations as well as windowing transformations. Now from here we can discuss that the size of the window is xw max minus xw min. This minus this, and the size on y coordinate y axis is this minus this. This is the size of window on x and y coordinate. In the same way, the size of viewport on x axis is this coordinate, means xv max minus this one, means this distance minus this distance. And in the same way, on the same way, in case of word, the coordinates m max coordinate minus min coordinate is the size of the word window on x direction, whereas size on the y direction is yw max minus yw min. So by using these coordinates, we can find out the size of our window or viewport. Now, if I have to map an image from window to viewport, then I have to map point by point. Suppose this is my image, this is my image, then what I have to do? First, I have to map this point over here, then I have to map this point over here, means we have to map each and every point here. This is, in this way we get the image from window to viewport. So we are not concerned about the complete image. What will given in exam, there will be a point, that will be given in the window, and we have to map that point to the viewport by the corresponding point xv and yv. We have to find this point, or sometimes, as I told, this point is given on the viewport and we have to find the corresponding point on the window. So this will be the question in the exam, that these coordinates will be given, or sometimes we have to find out these coordinates, but our purpose is to find out the coordinates. What can happen in the, sometimes what happens, they give the x coordinate, minimum value of x coordinate, and they said that the window size is, for an example, 50. So we have to find out this coordinate ourselves. We have to find out the value of this coordinate. So we have to find out the values of these. This will be our first motto. Now we will see that how we can map these points. This is our motto now, to find out the values of xv and yv. Now this is given that the window size of a window is given where the x coordinate w is written for window, as I told you v is written for the view. So this is x coordinate minimum and x coordinate maximum for the window, whereas y coordinate minimum and y coordinate maximum of the window same. This is x coordinate minimum and x coordinate maximum for the viewport, as well as y coordinate minimum and y coordinate maximum for the viewport. And this is the point that we have to map to the viewport. Suppose the coordinates of this is xw and yw. W represent window. So this is the x coordinate of window. This is the x coordinate of window, means the distance from y is the distance from y is xw, whereas distance from x-axis means y coordinate value is yw. Suppose we are taking that after the mapping, the coordinates in window will be y at y-axis, y at y-axis, and w, sorry, x and x-axis. So this is y and this is x. So this represents that x value for the viewport and y value for the viewport. This is the thing we assume, and these all other values are to be given. So now we will see the method that how we can find out these values. As I told you that we are either going to diminish the size or we are going to enhance the size. So what we will do, we will try to find out the scaling, that how much size we are going to increase in x direction, as well as whatever the size we are going to increase in y direction, corresponding to window and viewport, corresponding to window and viewport. Suppose this was the original size earlier as x, and now this is the s. Now this is the latest size, that whatever the ratio we are going to enhance on x direction, and this is the ratio, not ratio, this is the scaling on y direction. So we will try to find out the scaling factor, that is sx and xy, that we are going to be performed corresponding to x axis and y axis. So our first step will be to find out the scaling. So when I am going to find out the scaling on window to the viewport, so window scaling is the size of the window is, okay, let me draw this on the next page so that it will be more clear to you to understand the thing. I am drawing this over here. This is our window. This is our window. and this is our viewport. Suppose the size of this is this one. So this point is this point is X. We represent viewport, and this is min, means X min. This is means maximum size of this is X V max. X V max. Same if we are considering in case of y-axis for the viewport, that then this is the y-axis. This is the value of y-axis, that is y v max, and this is y v min. This is y v min. The same thing is in the case of window. In window, instead of V, it is represented by W. It is represented by W. So here it will be Y W Y W min, and at this point it will be YW max. On x-axis lower point it will be XW min, and maximum will be XW max. XW max. So these are the, so what I will do, I will try to find out the ratio of, I will try to find out the ratio of the length on x-axis to viewport and window. I will try to find out the ratio of length of viewport on x-axis to the length of window on x-axis. So when I am trying to find out the scaling factor in x direction, S represent scaling factor, S is for x side coordinate, y is for y side coordinate, S represent scaling factor. So when I'm going to find out the values on x-axis, scaling factor on x-axis, this is for window, this is for, this is for viewport, and this is for window. So I am trying to find out the length of this. So length of this is xv max, this is xv max minus xv min. So this is the length of viewport in x coordinate. So this is xv max, this is xv max minus xv min. So this is the length of viewport on x-axis, as well as this is the length of window on x-axis. Same when we will try to find out the scaling factor on y-axis, then this is the length of viewport on y-axis. So this will be yv max, this will be yv max minus yv min. This is the length of viewport on y-axis, and this is the length of window on y-axis. So we find the scaling factor on x as well as on y window. Now we will try to find out the scaling factor of the corresponding point. This is the point on window. We have to map this point on the viewport. So what we will do, we will try to find out this distance and this distance. We will try to find out the this distance and this distance ratio with this with this one. So first we will try to find out the ratio of this distance with this distance. I told you that we consider this point xv and yv, xv and yv. So when we have to find out the value or length of this from x-axis or distance of this from x-axis, then this is xv xv minus xv min. This is xv min. Xv minus xv min divide by xv max minus xv min. Xv max minus iv min. Same in the case of window. This is xw minus xw min means the distance from here to here. So this is xw minus xw min divided by xw means distance from x min means distance from these two, distance from x min to x max. So this is xw max minus xw min. Same it will happen in on y-axis also. So instead of x we put y. So this is yv minus yv min, yv minus yv min upon yv max minus yv min. Only we change the value of coordinate y instead of x. So we get these two equations when we are going to find out the corresponding value of the point, that is x v and y v. Now from these equations, let me clear it little bit. Okay, let me clear it complete. Now from this equation you can that that this is from the equation we are discussing from the first equation. This is xv minus xv min. This is same. What we did, we took the denominator. We took the denominator on the another side to solve this equation. To solve this equation. So this is the same part. This is the same part, and I am going to multiply the denominator of this over here. So when I am going to solve the equation number 3, then I am multiplying this over this. Now I know that when I am shifting this value, when I am shifting this value over here, so this will be xv max minus xv min upon xw max minus xw min, and from the equation we can say that this is equals to s x. So this complete will be equals to sx. This will be completely equals to sx. So I wrote this xw minus xw mean same over here, and I am multiplying with the scaling factor in x direction. So this is xv minus xv mean. You can see from here that the window and viewport, the value is same over here, only I am multiplying this value, that is the distance of window point, the distance of window point to the xw minimum, means minimum coordinate of window into sx, scaling factor in x value, and this is the corresponding to xv minus. So when I am again going to solve this, so I can move this in the right side. I can move this in the right side. So xv will be equals to this one plus this, and when it is in the minus, so it will be in the plus in opposite side. So next slide we will see this, that now I am shifting this. I wrote this, I wrote this equation again so that it will be more clear to you over here. We came at this, so this is xv minus xv min. From here you can see this is xv minus xv min equals to this one, and when I am going to shift over here, then this is xv equals to xv min plus xw minus xw min into sx. So by using this, we can find out the value of xv. Similarly, on y-axis also, I can find out the value, that is yv, by putting the y coordinate instead of x coordinate. So what we have to do, we have to find, these are the things, those will be given to us. Let me tell you once again. This is the window. In window, this is point P. So the values of this are XW and YW, XW and YW. So XW is given to us, YW is given to us. This is XW min. This is XW min. So the distance of this is given to us, XW min. So we can find, write the value of XW min over here, YW min over here. This distance in viewport, when we will draw the viewport also, the viewport, the distance of viewport from the x-axis is given, that is, this is given to us xv, this is xv minimum. So we can write down the value of xv minimum and yv minimum, and we can find out the value of sx and sy, that is scaling factor in x direction as well as scaling factor in y direction, and that is equals to, we can see on the last page, that sx equals to xv max minus xv min upon xw max minus xw min. Keep in mind one thing, that the coordinates or the values of the viewport is on the numerator, whereas the values of the window are denominator. So now we will try to solve one question based on this. By seeing the solution of the question, you will feel that it's really very easy. So consider a window. Window is given to us. Consider a window located at 0 to 100, 0 to 100, and a point from 30-30, and from 30-30 we have to map on a window on a viewport whose size is 0 and 50. Now if you will see, then for the simplicity they have given us that the coordinate of the window means x coordinate and y coordinate of the window origin are at origin means the value of xw min and xw the value of xw min and the value of yw min are 0 and 0, so that it will be more clear and more easy to understand the solution of this question. And it is the size is 0 to 100 means this is 100, this is 100, as I told you earlier that maybe they have given the length, so this is also 100, so we have to find out the coordinate means xw maximum. So when this is xw min is 0 and xw max will be 100 plus 0 means this will be 100, xw max will also be 100, same yw max also will be 100, and the point over here is 30 and 30, so the location of point P is 30 and 30. So this is given when we are discussing about the window that xw min is 0, this is xw min 0, xw max 100, we calculate this xw max 100, yw min 0 and yw max is 100. So these 2 points were given to us, and the width of the window was also given to us. Based on width and minimum coordinate, we find out the value of window maximum coordinate on x direction as well as on y direction, and the point P is also given on the window. Now we have to identify or we have to map this point on the viewport of size 0 and 50 means the size of the viewport is also start from 0 0 0 0. So this is y direction, y coordinate, this is x direction, so the x min and y min are also 0 in case of viewport, and the length is given 50, so we have to find out the value of max coordinate xv max, so this is 50, so this will be 50, and we have to find out the value of y coordinate also, so the length is 50 and minimum coordinate is 0, so this will also be 50. So this is given xv min 0, yv min 0, and we calculate these two, and now we have to find out the value of P dash. Suppose this will be the point, this will be the point corresponding to P, corresponding to 30 and 30. So now our purpose is to find out the value of P dash. So for that, I told you that first of all we have to find out the scaling factor on x direction as well as on y direction. Let me erase it. Yes. So first of all, we have to find out the value, that is Sx equals to xv max. This is xv max. This is xv max and xv min. So this is xv min. This is xw max. Xw max 100. Xw min 0. YV max, YV max 0, sorry, YV max 50 and YV min 0. Same, YW max is 100 and YW min is 0. So by using these values, we can find out the value of Sx and Xy. So let us first try to find out the values of Sx and Sy. So Sx equals to xv max minus xv min divided by xw max minus xw min. So here we find the value of xv max, that is 50 minus 0. So 50 minus 0 upon this is 100, 100 minus 0. So this is also 100. So 50 divided by 100 is 1 by 2. 50 divide by 100, this is 1 by 2. So scaling factor on x-axis is 1 by 2. Now we will try to find out the scaling factor on y-axis. So scaling factor on the y-axis is similar, only we have to put the value of y coordinate instead of x coordinate. So YV max, this is our YV max, this is our YV min. So 50 minus 0 upon YW max, YW max 100 and YW min 0. So this is 100 minus 0. So this is also 1 by 2. And you can see it from here that the length of window, the length of window is 100. Now the length of viewport in x direction is 50. So this is half. Same on the y-axis. Earlier the size of window was 100. Now it is 50. So this is also half. So this is the reason that I told you that scaling factor can be less than 1, can be greater than 1. When it is less than 1, in that case image is diminished. So when we have to find out the values of SV and YV, that from the last, from here we can find out XV equals to XV min. XV min means value of this plus xw minus xw min dot sx, means multiplied by scaling factor. So this is xv equals to xv min. This is our xv min in this case 0 plus xw. Xw is the distance of original point P on x direction. So this is 30. This is 30 and minus 0. Our value of xw min is also 0 in this case. So this is 0 plus 30 minus 0 multiplied by 1 by 2. Scaling factor in x direction is 1 by 2. So this is 15. Same when we will calculate the value of yv, this is also 15. So now the mapping of 30-30 from the window is 15, 15 in the viewport, 15 and 15 on the viewport. So these are the ways by which we have to calculate the values of viewport. In the same way, when the value of the point in the viewport is given, the value of the viewport is given like as it is given over here is 30 30. Sometimes it can be the case that value of this point is given and we have to map this point on window. There can be one more case to find out the coordinate, that sometimes they say that this is our window and the minimum coordinate, the coordinate of one end of window is suppose 10 10, and the coordinate of opposite side of the window are 50 and 50, or maybe y and, so this is 50 and 50. So in this case also, first of all we have to try to find out the value of x w min. We have to find out the x w min. In this case you can see that this is 10 and we have to find out the value of x w max. So here x w max is 50. So by any and how we have to find out the values of xw max and xw min, yw max and yw min. Same in case of viewport, xv max and xv min, as well as yv max and yv min. When we will find these two values, based on these two, we can find out the scaling factor on x and y direction both. And after that, by using this formula, we can find out the values of mapping point on viewport. So today we discuss about the mapping of viewport and window. First we discuss that what is the word image, what are the coordinates of the word image, means on x and y axis it can be from infinite to infinite, whereas window is the area that we want to see from that word image, that is the window, and the coordinates corresponding to window size is window coordinate, whereas the size on which we want to map that image, want to map window image, that is called the viewport, and the size that are coordinates of the viewports are viewport coordinates. We discuss about the word image and the window image. We discuss about the mapping of these two, then how we can find out how we can map the points from window to viewport. Then we discuss that how we can solve the values of the scaling. There is no need to remember these because it cannot be asked. Generally they ask a example on this, and the examples are based on the length as well as width of the window as well as viewport. But the questions may be tricky because there are different ways to find out the values of XV min, YV min, as well as in the window also, that is XW max and XW min in case of x coordinate, and on y coordinate, that is YV min and YV max, as well as YW min and YW max. So by using any method, we have to find out these values. This value also be given, and we have to find out the mapping of this point on the viewport. So by finding these values, we can find out the scaling on x-axis as well as on y-axis. After that, by putting the scaling value in this formula, we can find out the mapping point on viewport. So this was about the mapping of window to viewport. In the same fashion, we can do this from the window to viewport also. And this was the window and viewport complete discussion. Now I hope it will be clear to you. Now in next class we discuss about the 3D translation. As we studied 2D transformation earlier, in 2D transformation we studied different transformations techniques. So the same transformations technique we will study in 3D transformation also. Thank you.